Hello and welcome to our online class. Today we are going to discuss our third chapter of geography in class 6th social science book, that is motions of the earth. So we will discuss about the motions of the earth in this chapter step by step as per the NCERT syllabus. So first of all, let's see the content of this chapter which we are going to discuss now. First we have rotation of the earth, revolution of the earth, orbital plane, circle of elimination, leap year, orbit, summer solstice, winter solstice, and equinox. This chapter is very important for all the students, as you must be aware about the rotation, revolution, and how seasons take place on the earth, how days and nights are, you can say, formed on the earth's surface. So these all points we will discuss today step by step. First of all, let me show you this globe. When we see globe, clear picture of the earth come in our mind, as globe is considered as the miniature model of the earth. This globe may be large in size, it may be small in size. Sometimes we can carry this globe in pocket also. Now the point is, this globe or this miniature model of the earth is attached with one frame and 2 points. Here you can see on the top we have one point here at this corner, which is generally called North Pole, and the second point is here, it is called South Pole. So with an imaginary lines, this globe is having one axis in the center. Here you can see that on the axis this globe or our earth, it rotates. So you can see that it is the rotation position of the earth, although this globe is not in exact center of the frame. Here if you will see that here the center of this frame is here, whereas the point of this North Pole, it has come at this point. So you will find that our earth is tilted towards the poles, towards the, here this you can see that this is the tilted position of the earth. The earth's axis is not vertical but inclined, and it makes an angle of 66 degree with the plane of ecliptic, or which is called the orbital plane. It is tilted 23.5 degree from the line perpendicular to the plane of ecliptic. Here these are some of the imaginary lines. These lines which are shown here, just like this line, these are not real on the earth's surface. These are imaginary lines. So we will discuss about these lines in detail in our next slides. Let's see. First of all, try to understand the important term of this chapter, because when we talk about motions, then we discuss about rotation of the earth. Here rotation means the movement of the earth on its axis. Here we have seen in the previous slide. In previous slide, if you see that here, if we consider that this is an, if we consider that this point is an axis of the earth, so the movement of the earth or the motion of the earth on its axis, as you know that earth rotates on its axis, so that rotation, that movement of the earth on its axis, okay, in this way it is rotating. So this movement of the earth on its axis, although this axis is not a real line, it is the imaginary line, so this is called rotation. Now coming to this picture, here you can see that in the space, this earth, here it is in our solar system, this earth is rotating on its axis like this, means it is rotating. For example, we take one ball in our hand and start rotating on our palm only. So that movement of that ball at a point without changing its position, when we rotate that ball, then it is called rotation. Here you can see the rotation of the earth. Coming to the next slide, we have revolution. Revolution of the earth. This is totally different from the rotation, because rotation is at one place only. In rotation, any object or this earth is not changing its position, it remains on its axis. Here we had seen that it remains, if we see that this is the axis here in between, so it spins on its axis here only, means it is not rotating, it is not doing any revolution, not changing its place. Just like a ball, when we spin the ball in our hand, in the same way it rotates. But in rotation, in revolution, this position is totally different. What is the revolution? That movement of the earth around the sun. Around the sun. Just try to understand. Let me show you. Here it is. Here we have sun in the center. Okay. This is our sun in the center, and movement of the earth around the sun. Here you can see that earth has, means these are not for earth. Don't take this picture in other ways. This is only one earth, and this earth is completing its one round here. In this way it is completing one round around the sun in a year. Okay, so this complete round which is completed by this earth is called revolution, means this is the revolution. And this revolution of the earth is in a fixed path or orbit, means this earth can't come at this place or this place, or it can't go at this place in the corner. Earth has a fixed orbit, means that path in which Earth is completing its one round around the Sun is called revolution of the Earth. Here you can see that this revolution is in different phases, as I was telling you in the previous slide about the axis. Here you can see that in all pictures of the Earth, this center line, this line is called axis. This is called axis. So you might have seen that because of its tilted position, this is not in the center exactly, its tilted position means Earth has different seasons on our we have different seasons on our Earth. For example, in the month of June, if we go here, this point, here you can see that this northern hemisphere, as we have discussed in our previous chapter about the southern and northern hemisphere. So this northern hemisphere has come in front of the Sun in this position on 21st June. If you know, 21st June we celebrate as longest day in the northern hemisphere. And if you see that this position of the Earth here, this position of the Earth, in this position of the Earth, when it is tilted in eastern direction, that time the southern hemisphere is facing more sunlight. That's why 22nd December means is the longest day in southern hemisphere. So we will discuss about these hemispheres and other points in this video. Keep watching. Coming to next point, this is circle of elimination. This is circle of elimination. Circle of elimination. Circle of elimination, here it refers that, as you know, that our Earth, that is of spherical shape, means it's not completely like a ball. Earth is having geode shape or spherical shape. So you can see in this picture very clearly that this point, axis point, this axis point, here you can see in the center, it is an imaginary line. This is not the real line on the Earth's surface. All these lines, just like these vertical lines, these horizontal lines, which are called latitudes, and vertical lines which are joining the poles, which are called longitudes. These vertical lines, these are imaginary, these are not real lines. Okay, generally these latitudes are parallels to each other, these are not joining. We have 90 latitudes in this northern hemisphere upper part and 90 in the southern hemisphere. Same when we discuss about these longitudes, there are 180 degree longitudes in eastern hemisphere and 180 degree in northern hemisphere, in western hemisphere. So coming back here, what I'm trying to tell you, that when you see the position of the Earth, you find that this north pole means these poles are tilted. Okay, here 23 ½ minute, it is tilted on the line of perpendicular. Okay, means the earth is inclined and making 66 ½ degree. You can say that is the angle, the orbital plane of the earth. Here you can see in this map. But when sun rays comes towards the sun, only this area in front of the sun, means beyond the pole, is not receiving light. Along with it, this part up to the center of the earth, means when we see it once again, I will show you that this yellow part means the exactly half part of the earth which is facing the sun is receiving sunlight, and the back side part of the earth, this you can see, it is not getting any sunlight, and it is observed as a night. Whereas this part of the earth which we are discussing here, this is observed as a day. So this circle of illumination is making day here, this side which is facing the sun, and night back side. Because when you do an experiment at home by taking one torch, you just lit that torch on any of the bowl in a dark room, you will find that only half part of the bowl is getting light. The same is with our earth, that exactly half part of the earth is receiving light. Sometimes you can say in the north pole is coming in this zone, sometimes south pole is coming in this zone. So it's up to the revolution of the earth. So this position and this line which is dividing the earth into day and night, this central, here you can see this line in the exact center of the earth, because sunlights can be received by this part only, not the back side. So this part means this line is dividing our earth into day and night, which is called a circle of illumination. I hope that this point, circle of illumination, is clear to you, because it, you can say, this circle divides the day from night on the globe. Okay, the circle does not coincide with the axis. You can see here, axis is not a matter in this circle of illumination. It may come in the light portion. When this period we will discuss in another slide, come to the next slide, Earth Day. Our Earth takes about 24 hours to complete one rotation around its axis. When you may say the previous slide, here you can see that Earth Day refers to completion of one round of the earth, means if it starts from here, then it will complete one round in 24 hours, because this time earth is rotating on its axis. Here this time earth is rotating on its axis. So this completion of round by the earth on its axis is called rotation, and this is called Earth day. Our Earth completes this day in 24 hours. Okay. Meanwhile, one rotation round around the axis is in 24 hours. Coming to next slide, here you can see seasons of the earth. Generally you are experiencing winters, summer, spring season and autumn season. So this is not the miracle on the earth. This is not a miracle that God has done this miracle. No, this is a scientific fact that these seasons are made. Why? Because our earth has, you can say, a position, that tilted position on which it is inclined and tilted towards the poles. Okay, when you see this picture, next one, you can see here that because of its tilted position on the poles or on its axis, here these seasons are made. Now you can see in this next picture, one more picture, you can clearly understand here that this one, this in the center we have sun, here we have sun, right? So in the month of June, when it comes, especially on 21st of June, in this position here, this position, so this time you might see that here the northern hemisphere is experiencing more sunlight. Okay, in northern hemisphere there is more sunlight, which is called longest day in northern hemisphere on 21st of June. So there are summers in northern hemisphere at this time. Because of extreme heat, sunlight, sun rays directly fall on this hemisphere, especially on Tropic of Cancer. Okay, at the same time southern hemisphere, if you see this portion near the south pole, this hemisphere is experiencing winters because sun rays are not reaching in this region. This is the first point you can understand, that summers and winters are there in this region. Secondly, when we see that in September, in the month of September, when earth it comes here, opposite direction, and sun is here in the center, so there is these rays are equally coming on the earth surface, means up to this central part equal. Okay, so here you can see that on 23rd September, means the season is autumn in northern hemisphere and spring in the southern hemisphere. If we see the direction, third direction of the earth here, you can see this point. This time, because of its revolution, this is revolution movement of the earth, that earth is completing its round around the sun, means this is revolution. So this time, this southern hemisphere, southern here it refers south hemisphere, southern hemisphere means it is facing the sunlight. This part is facing sunlight, whereas northern hemisphere is not receiving light. That's why in December on 22nd we have winters in northern hemisphere, means shortest day, and summer in southern hemisphere, means that is the longest day for them. Okay, now coming to this position of the earth, in which again it comes here on the top or in the opposite direction. So sun rays fall directly on the half part of the earth, and it is also called equinox. And southern pole, southern hemisphere, it experiences autumn season, whereas northern hemisphere is experiencing spring season. Coming to our next previous slides which we had to discuss. Okay, these were the formation of seasons, which I told you that how seasons are formed. So 4 seasons we discussed. First is summer, winter, spring and autumn. So these seasons are made due to revolution movement of the earth, because earth is taking revolution around the sun. Coming to next point, that is orbital plane. Here orbital plane refers to the axis of the earth, which is an imaginary line, as we had discussed that axis is imaginary line. We don't have any line on the earth surface. Real lines are not there. These lines are drawn, you can say, to get the exact location of the earth. From the satellite you can see that, or when we take picture we can understand that what is the exact place of any area. Makes an angle of 66 and half degree with its orbital plane. The plane formed by the orbit is known as orbital plane. Here you can see that this is the axis of the earth joining north pole to south pole, whereas the circle of illumination in the center, means that is here in the center, exactly in the center, vertical line which is joining one edge to another edge. So you can see that it is making one orbital plane on this equator. Here 66 degree 30 minute, because our earth is tilted 23 degree and half minute here towards the sun or poles. On the poles this is tilted, this portion is the tilted position, this 23 degree, this is the tilted position. Okay, coming to our next slide, leap year. What is leap year? We hear most of the time that somebody's birthday is coming in every 4 years. Means is not, that boy is not celebrating birthday every year. So if you will ask him, why are you not celebrating your birthday every year, you will get the answer that his birthday is coming on 29th of Feb. Because this 29 Feb is not coming in all years. It is coming after every 4 year. That year we have 366 days in a year. The reason is that when earth, you can say, revolves around the sun, it completes its one round in 365 days 6 hours. So we consider these 6 hours for our convenience. Means we do not add these 6 years in 1 year, and we keep adding these 6 years to make 26 hours to make 24 hours. I am repeating once again. Just consider that earth is completing its one round or revolving around the sun in 365 days and 6 hours. Okay, so we take 365 days as 1 year, because 6 hours we are not counting in each year. So what we do, we add these 6 hours, you can say, to make one complete day in 4 years. So this extra day is added in the month of Feb. In the month of Feb, we add this day as a 29th Feb. Okay, generally in leap year we have 29 days. So this year is called leap year. Means the year which is having one extra day, or which can be divided by 4, is called leap year. Coming to this equinox. Equinox, as I told you, that equinox is the position of the earth, means on 21st September and on 21st March and 23rd September, direct rays of the sun fall on the equator. Here I am showing you in one of the slide. Here you can see that direct rays of the sun fall on equator on this day. Here you can see that this sun is in the center, and in this position, this is the equator. This is the equator of the earth. So here on 21st March, and at this position on 23rd September, 21st March and 23rd September, you can see these 2 days, direct rays of the sun fall on equator. You can see that this central line of the earth, which divides our earth into 2 equal halves, that is called equator. Neither of the pole is tilted towards the sun. At this position you can say that neither north or south is tilted. Complete half portion of the earth is receiving sunlight. Okay, so the pole earth experiences equal day and equal night. Meanwhile, on 21st March and 23rd September, we have equal day and equal night on the earth's surface. This is called an equinox. I hope that this point is clear to you, that equinox refers to equal day and equal night because of the position of the earth, because it has gone completely in the opposition. Okay, so complete one half portion of the earth, southern hemisphere, is getting full light, and equator is receiving the sunlight. And when it goes in the opposite direction in the month of September, you can say in the month of March, the southern hemisphere is receiving the light, and in the month of September, this northern hemisphere is receiving the light. So this equal day and equal night is on 21st March and 23rd September. It is called equinox. This you have to understand, that equinox, what is that. Coming to winter solstice. Winter solstice. Now you will come to know what is this winter solstice. This position of the earth on 22nd December, means when we see the diagram here, on 22nd December, meanwhile in the month of December, when the Tropic of Capricorn receives direct rays of the sun. Here it is sun we have, and this portion, this Tropic of Cancer is in the southern hemisphere. It is 23 degree 30 minutes south. So this Tropic of Cancer is receiving direct rays of the sun as the south pole tilts towards it, because this time you can see the position of the earth, that it is tilted, means while this only south pole is receiving more sunlight. So large portion of the southern hemisphere gets light on this day, and generally summers are observed in this hemisphere with longer day and shorter nights, because nights are short. At this time there is a complete opposite position of the earth, opposition season in the northern hemisphere. This time northern hemisphere is having shortest days. Okay, means in northern hemisphere people, they find winters. When there is summer in southern hemisphere, there is winter in northern hemisphere. Okay, so this position of the earth is called winter solstice. I hope this is clear, that when sun rays fall on Tropic of Capricorn, because of its tilted position, because that Tropic of Capricorn has come in front of the sun this time. So this position of the earth is called, you can see that this position of the earth is called winter solstice. And now I am showing you summer solstice. Here you can see that in the month of June, you can see that Earth's position is tilted towards the sun, and this northern hemisphere part, this part, it has come in front of the sun rays, whereas the southern hemisphere portion, it has gone in the back side. Okay, means tilted rays are going towards this area. So Tropic of Cancer means receives direct rays of the sun. As the result, this area in northern hemisphere receives more heat and sunlight. The areas near the poles receives less heat, as the rays of the sun are slanting, because sun rays are slanting rays. The north pole is inclined towards the sun, as we can see that this time north pole is towards the sun, and the places beyond the Arctic Circle experiences continuous daylight for about 6 months. Since the large portion of the northern hemisphere is getting light from the sun, it is summers in the region north to the equator. The longest day and the shortest night at these places occur on 21st of June. At this time, southern hemisphere means that is having winters. So the nights are longer than the days in this position of the earth. This is called summer solstice. Here you can understand that summer solstice. Okay. Now coming to one fact which is given in this chapter, that Aryabhatta, an ancient Indian astronomer who was in the Gupta period, he stated that earth is round and rotates on its own axis. So most of the points of this chapter we have covered. Kindly note down these points in your notebook and learn these points. Okay. Thank you very much. Keep watching the videos of social science.